Hi, so this is the ferromagnet lab. So right now I have the solution which has vegetable oil and toner in it, as well as I got a neodymium magnet from Home Depot. So I don't know why my camera has a black set. Here we go. So in this experiment, I don't know if the camera's gonna be able to pick it up, but there's spikes that come out of the fluid when you move the magnet around. I'm going to explain as to why it does that. So, the ferromagnetic material exhibit the largest magnetic permeability. So ferrofluids are composed of ferromatic particles, which is like surfactant, laundry detergent, or dish soap, and carrier fluid, which is kerosene, vegetable oil, and mineral oil. So ferromagnetic materials are used because they're large magnetic permeability compared to other classifications of magnets. So the resultant magnetic field is orders of magnitude larger than the induced magnetic field. So this means that this becomes important when manipulating ferrofluids under moderate and controlled magnetic fields. So a typical ferromagnetic material consists of iron, nickel, and cobalt-based metals, and occasionally rare earth materials such as neodymium, which I used, neodymium, chromium, and iron oxide compounds. So, and some examples of oxide compounds are like I think it's pronounced like magnetite. So moving forward, ferromagnetism is caused by a long-range atomic scale ordering that causes unpaired electrons to align parallel with each other in a domain. So these domains or regions are about 1 millimeter linear dimension of magnetic alignment, are randomly oriented and confined within the bulk material, leading to a net magnetic field of 0. However, under an external magnetic field, these domains align, causing an amplification of the applied magnetic field. So that's what's essentially causing the, wish you could see it better, but the pins in the fluid to like pop up. I just put vegetable oil on my laptop. So I just cleaned up the vegetable oil. But to go off of that, so, the domains that are created under the atomic scale, long-range ordering may span to over large numbers of atoms. So, however, to make a ferromagnetic material fluid for our purposes would require melting the metal. So, under such conditions, typical ferromagnetic alloys have melting points in the excess of the point when ferromagnetic properties transition to paramagnetic. So this transition is denoted as the Curie point of temperature. So in conclusion, the ink toner, also which is used in laser printers, contains 40% of fine iron dust at nanoscale, which usually has a diameter of 10 nanometers or less. So these nanoparticles of magnetite and hematite contain iron. So the ink toner is mixed with vegetable oil to make a viscous colloidal liquid, which is also known as ferrofluid. So ferrofluids are colloidal liquids made up of ferromagnetic particles with fluids that are usually organic like oil and water.